All right, so we're going to get our last method for solving quadratics today, and that's going to be the quadratic formula. Now, the big advantage of the quadratic formula is that it works for every quadratic. Hands down, it works. Now, on some of the problems, it will specify what method you have to use, and you have to use that method, and it says in the directions, if you don't use that method, then you won't get any credit for that problem. So, we're going to talk a little bit today about how you might pick out a different method if you had a choice. And on your homework, it will say using any method. I think this is going to work. So, whoa, that got really loud. I hate these things. All right. I really hate, like the other one's not that bad, but until it's still not showing up as registering. All right, we'll give it a try. Apologize if you're one of the people that watches these. This doesn't record right. So, simplify. So one of the biggest problems that people have with these quadratic formulas, it's not using the formula. The formula is pretty straightforward. Put the numbers in their places, simplify using arithmetic. But coming down to the end where you have to simplify is where it can get questionable. So these examples here are what your answers might look like after you've used the quadratic formula, but before you've simplified. So we're just going to learn how to simplify, and then we're going to go back and do the whole problems ourselves. So there's two different methods that you can simplify. I prefer method 2, and I'm going to use method 2 all of today, but they have the same first step. And that's if you want to simplify one of these answers, the first thing you always simplify is the radical. You never simplify the fraction until you've simplified the radical. If you can't simplify the radical, you stop. You're just done for the problem. You stop there. So this is what an initial answer is going to look like. And the first thing you always try to simplify is the radical. So can I simplify the square root of 44? Do any of my perfect squares evenly divide into 44? 3. 4 and 11. So I have a chance to simplify this because for the square root of 44, I can do the square root of 4 times the square root of 11. So I've got to do that. And that's the place to always start is the radical. Always start with the radical. So the square root of 44 is the same as 2 times the square root of 11. So what I want to do now is rewrite my initial answer, but put in 2 square root of 11 in place of the square root of 44. Everything else around is the same. Now the second part, you've always got to start with the radical. The only way I could possibly simplify the fraction is if I can find a GCF to all 3 coefficients or constants. So the second term here has the coefficient. Doesn't matter if there's an I, doesn't matter if there's a square root. So I want to see between these 2 constants and this coefficient. And I've had students call us, I use the triangle method before. So what I'm looking for is a GCF to all 3 of those. And we did this back a little bit in Unit 2. And if I don't have a GCF to all 3 of them, I stop there. If I have a GCF to all 3 of them, I divide it out. So do I have a GCF for 2, 2, and 12? 2. So I'm going to divide all 3 of those terms by 2. So 2 divided by 2 is 1, plus or minus. Now if I divide the second 2 by 1, I get another, or sorry, by 2. I get 1 again, but this time it's going to be 1 square root of 11. It's not just 1 by itself. And 1 times the square root of 11 is still the square root of 11. So when the 1 is a coefficient on that second term, we don't necessarily have to write it in there. Because saying 1 square root of 11 is the same as the square root of 11. And then that's all over 12 divided by 2, 6. And that's how I could leave my answer fully simplified. You could, yeah, I'm not going to take off for that. The only time you really, really wouldn't put the 1 is if it's the denominator. Because dividing by 1, never going to make a difference. So if I look at the second problem. We want to simplify this. You always start with the radical. If you can't simplify the radical, you can't simplify the problem, period. You just move on. So what could I do for the square root of negative 18? It's imaginary, so I'm going to start, I'll take a square root of negative 1 out. That'll get us to our imaginary unit, or just throw an I out front, square root of 18. How about the 18 by itself? Can I break that up at all using my list of perfect squares? 9 and 2. So negative 1, 9, and 2. So the square root of negative 1 times the square root of 9 times the square root of 2. And then I can simplify the square root of negative 1 and the square root of 9. So I have 3i times the square root of 2. So I'm going to take my whole problem and just replace the radical. Now, sometimes that's all you can do. But the second thing to look for, again, your problem may end there. The second thing to look for is to draw, I'm going to draw my triangle around the numbers. It's okay that there's an I there. We don't consider it in our simplification. We don't consider the radicand either. It's just the numbers there, the 3 of them. I look for a greatest common factor to all 3. 3. So I can divide all of these by 3. So 9 divided by 3 is 3. Plus or minus 3 divided by 3 is 1. Now because there's other stuff after it, you don't necessarily need the 1 there. It's going to be 1i square root of 2, which is the same as I square root of 2. And then 12 divided by 3 is 4. Now there's still something wrong with this answer. Why do you have to break it up? This is a complex number. So the answer is not real. And the directions on the whole problems will say this. If you get an imaginary answer, write it in the form a plus bi. So this is like what we did at the end of 10.7, where we ended up with those big fractions, and they were all kind of mashed together, but we have to write imaginary numbers as a plus bi. So this isn't in the form a plus bi, which is the form any complex number should have. So in order to get it to the correct form, all I do is separate 3 over 4 plus or minus I square root of 2 over 4. So I just take each term of the numerator and give it its own denominator, because then it's in the form a plus bi. Ashley? Yes. Yes, that's the only time you have to do that, is if you have an I. I wouldn't do it any other time. Then you would simplify that fraction. Yep. And we'll do that in one of the problems that we work out, the whole thing. Any other questions? Again, the directions on your homework, the directions on your drills, the directions on your tests will all say write imaginary answers in the form a plus bi. So you'll have that. Now the next one would have been a problem that you worked out. You got a perfect square, so you simplified it, so there's no more radicals. It was real, so there's no i's. This is just like when we completed the square. When you had no radicals, no i's, you've got to break it up and get 2 answers. So no more radical, no i's. You've got to go through and work out that definition of plus or minus, which is first do negative 4 plus 10 over 3. So that's taking the plus from the plus or minus. And then negative 4 minus 10 over 3. So the first one is 6 over 3, which gives us an answer of 2 when you simplify it, It's just an extra step to simplifying because we have a denominator here. And then for the second one, we're going to have negative 4 minus 10 is negative 14 over 3, which can't be reduced, so it's okay. Just leave negative 14 over 3. So the only time you need to break up the plus or minus, the same as before, is if you have no more square root and you have no i's. Questions? All right, so the last one we're going to simplify. What's the first thing you always look to simplify? The radical. You don't do a GCF until after the radical. So I look at the square root of 15, and using my perfect squares, what can I do for the square root of 15? Nothing. So if I can't simplify the radical, leave it. You're done. Nothing else is going to happen. Because, so that's it. If I'm going to simplify the fraction, I need to be able to make the triangle and find a GCF for all three numbers. You don't include the radicands in that. We never divide out of radicands. What's the coefficient of the square root of 15? 1, which isn't going to simplify at all with the other numbers. Most you take out is 1, which doesn't change anything. So if you can't simplify the radical, that's where you leave it. That's where you're done. And of course, we're going to do this 4 more times with each one of our examples. This is like the end step, but I find this can be confusing if we try to do everything all at once. So are there any questions just on how we simplify? All right, let's go through and do the whole formula then. So there's your quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So for the most case, this is just plug in numbers. Plug in your a, b, and c. There's only one step to the setup here. So we had a couple steps for setup in completing the square. The only step for the setup is that this has to be in standard form, which means it's equal to 0. That's our only setup for using the quadratic formula. We like a to be positive, not a big deal if it's not. So the only thing for setup here is that the whole quadratic has to be equal to 0. And the quadratic formula will work to solve any quadratic. It's not always the most efficient method though. So we're going to talk about in each problem, if you had a choice, what might be a better choice if there is one. So after we've got our setup done, we're going to identify A, B, and C, just like we did when we factored back in Unit 1. Same A, B, and C. A is with x squared, B is with x, C is a constant. So the directions say solve using the quadratic formula. If the directions specify, you have to use that method. Sometimes they'll just say whatever method you want, then it's up to you. But if it has a specific method, make sure you know what that method means. So quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'm going to write it out each time we do a problem, just because as you learn it, the more times you see it, the more times you write it, the better off you'll be learning. So what we need to do is we need to come up with A, B, and C, and then we just substitute them in. So if I look at my original problem, the only thing I need for setup is it needs to be equal to 0. My quadratic needs to be equal to 0. Which, for this problem, I've got. Now I need to identify A, B, and C. So if you look at your problem, what's A? 1. A is the number in front of x squared, just like when we factored with the AC method. B and c, constant on the end, is 15. So the other really big area you can kind of flub up is just substituting wrong. Well, if you don't know your formula, you're cooked for these problems. But other than that, whenever you substitute, just put parentheses around the numbers you're substituting in. So negative, I'm replacing b with 8, so I'm going to put parentheses around it. Plus or minus the square root. B I'm again replacing with 8 in parentheses, so 8 squared, minus 4 times 1 in for A times 15 in for C. And my division goes under all of that, not just the radical. It's another place that people tend to make mistakes when they start. All over 2 times A, which I'm replacing with 1. So everywhere I replace a letter with a number, I use parentheses. Particularly if you rely on your calculator for arithmetic, use parentheses. And now it's down to the arithmetic part, and then simplifying like we did on the front. So first thing to decide is the sign on the term out front, which it's just negative 8. Sometimes we end up with 2 negatives, but it's just 1 this time. So negative 8 plus or minus the square root. If you have a calculator, a graphing calculator, or a scientific calculator that holds display, you could enter, just as we have it written here, the whole radicand. Don't enter the square root part, but just enter the whole radicand, and it will give you the radicand in 1 step. I'm going to do the whole thing by hand, so I'm going to do it in 2. So the first thing I'm going to do is square the 8. So 8 squared, 64. Now, for the next part, sometimes there's a minus here, sometimes there's a plus here. It all depends on what you're multiplying together. So what I recommend is don't write a sign yet. Treat this as a negative 4 and multiply these 3 numbers together. So negative 4 times 1 is negative 4 times 15 is negative 60. So we know it's minus 60 for my negative 60. Sometimes if you have enough negative numbers, it turns back into a positive there. So just treat that 4 as a negative 4, multiply those 3 out. And then multiply your denominator. 2 times 1 is 2. So now we have x equals negative 8 plus or minus the square root. 64 minus 60, so the square root of 4 all over 2. And then when you go to simplify, what's the first thing you always simplify? Radical. So, well, radicand is pretty, do you say radicand? Pretty close. I mean, that's the number under the radical. So the radical. So square root of 4. Well, that one's going to be easy because it's one of our perfects. So I can replace the square root of 4 here with 2. So I have negative 8 plus or minus 2 over 2. Make sure when you write this that your bar extends under the whole thing. Now there's a couple of different ways you could finish this off. Does anyone have a suggestion for one way? Ree, what do you think? Divide everything by 2. So now we're down to having the 3. I don't need to worry about excluding a square root because I don't have one. So I could go ahead and just divide these all by 2. As long as you get all 3 of them, you're okay. So negative 8 divided by 2 is negative 4. Plus or minus. Now how about when I divide this 2 by 2, do you think I need to leave that 1 or can I leave it off? I need it. I need this because there's nothing else there. So if I leave it off, then I'm going to be missing a whole term of my problem. Now, again, my denominator is 2 divided by 2. Do I need to leave that 1? Or I can drop it off. That one I can drop off. Because dividing by 1, that's not going to change it. But this one I absolutely need this time because it's not a coefficient for something else. It's that whole term. And what else do I have to do before I go ahead and box this answer in? Yeah, this is the one time when you have to split this up. Do negative 4 plus 1 and negative 4 minus 1. So we get x equals negative 3 negative 5. Now your other option would have been at this stage right here, instead of dividing by 2, you could have split. You could have done negative 8 plus 2 over 2 and negative 8 minus 2 over 2. And you would still get a negative 3 and a negative 5. So it's up to you whether you simplify and then split, or split and then simplify. They both work out the same. Now let's say that the directions didn't specify a method. I would not use the quadratic formula on this particular problem, personally. It's going to be a lot more time than for this one. I would solve it by factoring if I had a choice. The only time I solve by factoring from now on is if it's the shortcut or perfect squares. Don't waste your time with a full AC method, because you're going to have to spend time, is this factorable, is this not factorable? But if you look at this, when it's equal to 0, can you multiply to 15, add to 8? 5 and 3. X plus 5, x plus 3, set them equal to 0, you can get your answers. It's a lot less work than this. Another option that would work for this problem pretty easily, this would be another candidate for completing the square. And the only time I'd ever complete the square if I had the choice, if you don't like completing the square, don't do it unless you have to. But when A is 1, if B is even, it's the only time I would complete the square if you had a choice. Because when you go for that b over 2, if this is odd in the middle, it makes a mess of fractions. So the easiest way for this problem, probably factoring. Quadratic formula always works. Something else that wouldn't be too bad for this particular problem would be completing the square. So really any of our methods, except for the squared property by itself. Questions? All right, for B, directions say solve using the quadratic formula, which means you have to use the quadratic formula if you want credit for this. So first thing we should always be concerned with is setup. So setup to use the quadratic formula is simply must be equal to 0. So I don't have my setup for this problem. So what can I do to very quickly fix that, Ashley? Yeah, absolutely. Add 3 to both sides. So that's going to make the right side into my 0. So I have x squared minus 5x plus 3 equals 0. And to use my quadratic formula, I need to know what a, b, and c are, and you can only get those if you're in standard form, which means equal to 0. So A again is going to be 1. B is negative 5. And C is 3. So my formula is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So once I plug my numbers in and simplify, I've got my x. Now, you got to be careful with this one because b is a negative number and there's a negative in my formula. I need both of those negative signs. So there's a negative in the formula. The number I'm substituting in for b is also a negative. So I have a negative 5 out front. Plus or minus the square root, b squared, use parentheses around these negative numbers. Even if you're not using a calculator for it to be correct, you should have parentheses. Minus 4 times 1 times 3, all over 2 times 1. Again, when I say all over, take it all the way back to the equal sign. Now, my front number here, first term is negative 5. What happens when I have the two negatives right next to each other? Turns to a positive. So this is now positive 5 plus or minus the square root. Negative 5 squared is 25 And then I'm going to treat these last factors, 3 factors, I'm looking at the 4 that it starts with, 3 factors as negative 4 times 1 times 3. And that gives me negative 12. So this is minus 12. All over 2 times 1 is 2. So I have x equals 5 plus or minus the square root. 25 minus 12, square root of 13, all over 2. Why would it be the final answer? Can't simplify the square root of 13 means you're going nowhere with simplifying. Yes. So look at your radical. Can't simplify the square root. Can't simplify anything. So we're done. And for this answer, I just got asked in other classes. I don't need to split it up into 2 separate fractions because there's no I. The only time you have to split it into 2 separate fractions is if you have an I. So this one I could leave all stacked together. Questions? Now in terms of if I had a choice, I would use the quadratic formula on this. I wouldn't do anything else. B is odd, which makes completing the square a little bit more difficult because you're going to have to work with fractions, and it's not factorable. So we have no other method that will work. I can't find a pair that multiplies to 3 adds to negative 5. All right, C, 3x squared plus 7 equals 8x. So the directions say solve using the quadratic formula, which means you have to use the quadratic formula. Set up. There's only one thing to set up here. It's got to be equal to 0. That's your only setup for quadratic formula. Well, my problem's not equal to 0. My problem's equal to 8x. So I've got to fix it. How could I get this equal to 0? Subtract 8x. And when I subtract the 8x on the left side, where should I put it? Yeah, in the middle. So that I see that descending order. 3x squared minus 8x plus 7 equals 0. Now, it's not the end of the world if you don't, but then you have to be very, very careful when you pick out A, B, and C. Because A, B, and C are not just first, second, third, which we'll see on our last problem. A is always with x squared, B is always with x, C is always a constant. So I have A is 3, B is negative 8, and C is 7. And even if I didn't put that in descending order, say I just tagged the 8x, negative 8x on the end, A is still in front of x squared, B is still in front of x, and C is still the constant. The order doesn't matter. It's what it's attached to. But it's just easier if you put it in descending order. So now our formula is x equals negative b plus or minus the square root of b squared minus 4ac all over equal sign to the end 2a. And substitute in your numbers. So I have a negative in the formula and a negative on my b. So negative, negative 8. Plus or minus the square root. Use parentheses every time you substitute. Negative 8 squared minus 4 times 3 times 7. The whole thing over 2 times 3. So again, I have a negative and then another negative on that first term, which means it turns to positive 8. Plus or minus the square root. Negative 8 squared is 64. That first term under your radicand should always be positive if you're doing this with 2 terms. And then negative 4 times 3 times 7. That tells you what sign and what number come next. So negative 4 times 3 times 7 is a negative 84. So minus 84 all over 2 times 3, 6. So we're looking at 8 plus or minus the square root of negative 20 over 6. What's the first thing to simplify? Radical. So what could I do for the square root of negative 20? Square root of 4, square root of 5 would be for the square root of 20. What else do you need? Yeah. So negative 1 for the negative for the fact that it's imaginary, and then the square root of 4 times the square root of 5. So the square root of negative 20 is the same as 2i times the square root of 5. So we have 8 plus or minus 2i square root of 5 all over 6. Sometimes that's all you can do, just simplify the radical. Sometimes you can't even do that. But is there anything else I could simplify here? Yes. Yep, even when we had one on the front where there was an I. Oops, go back one more. So like this one had an I, you just leave the I and the square root out. Yes, you can still do that even if there's an I. So looking for a GCF to all three of these, which I think I heard somewhere was divide them all by 2. So 8 divided by 2 is 4, plus or minus 2 divided by 2 is 1. Do I have to put this 1 here? No, because 1 times, there's other stuff there, so I don't need the 1. So I just need the I times the square root of 5 over 6 divided by 2 is 3. Am I ready to box? I need to split it up. This one's imaginary. Imaginaries need to be in the form a plus bi. So we're going to have 4 over 3 plus or minus I square root of 5 over 3. And for this particular problem, if directions did not specify, I would use the quadratic formula. If a is anything other than 1, I typically just default to the quadratic formula. If you tried to complete the square, so it's not factorable, you don't have a real answer, it's definitely not factorable. If you try to complete the square, the first thing you have to do for that setup is divide everything by 3, which then creates negative 8 over 3 for b, which you have to divide that by 2, and then square it, and add it to both sides. It's a mess. So, generally speaking, for myself, if a is not 1, just go right to the quadratic formula in your quadratics. So the last problem we have is x squared minus 6 equals 0. It doesn't look like our other problems, but we can still solve it using the quadratic formula. You follow the same steps. So the first step is always make sure you have your setup. For the quadratic formula, it has to be equal to 0, which I've got that. Now the part that people mess up is the next step. I need A, B, and C. But I'm missing one of them. Which one am I missing? B. It's not just first, second, third. A is always with x squared, B is always with x, C is always the constant. So I've got the x squared, its coefficient is 1. I do not have the term that just has the x, which means I don't have b. C is a constant. I have my constant, negative 6. So what do you think, if we're missing that b term, what do you think goes in for b? 0. I have 0x. Look at it like that. But using the formula is exactly the same. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Oops, I put some numbers. I put half my numbers in. Sorry. Just going for generic. Now I'm going to substitute in all of my numbers. So negative b is 0 because we don't have the middle term, plus or minus the square root of 0 squared minus 4 times 1 times negative 6 whole thing over 2 times 1. Now, 0 does not get assigned a sign. 0 is not positive or negative. So saying negative 0 is the same as just 0. So 0 plus or minus the square root. Well, 0 squared is also 0. Now, before you put your sign down, treat this as negative 4 times 1 times negative 6. What's going to be the sign between 0 and my next term? Plus. So it's plus 24, because that's a positive 24 when I multiply them together. All over 2 times 1 is 2. So I have x equals, now, if I have 0 and I add 5 to it, have I changed the 5? 0 plus 5 is what? 5. How about 5 minus 0? 5. So having the 0 before the plus or minus doesn't change it at all. It does not change it at all. So I'm not going to write the 0 out front. Keep the plus or minus. Yeah, plus or minus still has to be there. And then the square root of 0 plus 24 is the square root of 24 over 2. And now we're going to simplify the square root of 24. How can I break up the square root of 24? Square root of 4 times the square root of 6, which gives me 2 square root of 6. So I have x equals plus or minus 2 square root of 6 over 2. And since there's only 2 terms now, I don't need to do the triangle because there's not 3 things to divide from. There's only 2. So if I can divide from those 2, I'm all set. So simplify this further. I can get rid of the 2 over 2. So I have x equals plus or minus the square root of 6. Now, in reality, I would never use the quadratic formula on that problem unless I had to. If you're missing b, that's like what was on your drill today. I could do this whole problem using the square root property in 2 steps. So just to illustrate, it's not always the most efficient. That same problem, if I were using the square root property, I'd add 6 to both sides, take the square root. X equals plus or minus square root of 6. Much, much faster. So play around with methods on those last 4. On the first ones, you have to use the quadratic formula. If you have questions, let me know. Otherwise, have a great weekend.